4. Fundamental theorem of calculus. This is what you do all the time. Fundamental theorem of calculus. Okay? Evaluate a definite integral using the fundamental theorem of calculus. Understand and use mean value theorem for integrals. Find the average value of a function over a closed intervals. Understand and use the second fundamental theorem of calculus. Understand and use net change theorem. By the way, all these things you can use in your physics class, and you can use this one as your, if you're working at the factory to trying to optimize some places, you can use all these. Okay? So this is like if you are, which the industry tech majors, yes, you can use this one. You can a computer science major, yes, you use this one. We use a lot. Fundamental theorem of calculus. Okay, you don't have to worry about this. So they were trying to tell you, differentiation and integral is not two different things, but they are what?
Same.
They're what? Opposite, inverse of each other. They're giving you graphically. They're saying this is a slope. That's what differentiation. Right? What's your integral? I'm looking at the what? Area under the curve. That's what they're saying. So they're not two different things. I'm looking at the same graph. In one way, it's looking at what? How fast it's moving. It's a differentiations. I want to see how much area under the curve. That's what? Integrals. Are you with me, class? Okay. So we know this one. Remember we've been doing the problem that we've been using? Subtracting upper limit minus lower limit. You know I get to do this because of this, the fundamental theorem of calculus. The fundamental theorem of calculus says if function f is continuous in closed interval a and b, f is antiderivative, f is what? Antiderivative of f on interval a comma b, then this is what it is. Remember the problem we have like this? Remember I do what? Antiderivative, which give you what? X squared over 2. And then what did you do? I evaluate this from where? 1, 2, right? So this right here is what? 2 squared over 2 minus what? 1 squared over 2. So this is my f of what? 2. And this is my f of what? 1. That's what they're talking about. I've been doing this because I know about this fundamental theorem of calculus. Are you with me? We've been using it in lesson 3 because I know we're going to talk about it here in lesson 4. Yes, I've been using it because of this theorem. This theorem gives me what? Permission to solve it like this, okay? Because I know I can do that because there's a theorem and personally approved this, okay? That's why I like theorems. I may not prove the theorem, but I know there's somebody else already proved, so I can guarantee to use it. All right, so is everybody with me? So if I finish this one, this just means what? 4 over 2 minus 1 over 2, which gives me what? 3 over 2. That's my area, all right? So that just give you an example. But we don't have to do this example because we know how to do. Okay, how would you do this problem, class? I'm not going to do it, but just think about how would you do this. I need to rewrite this one as what? That's right, x to the 1/2. Then I know what to do, right? All right, now what I do what? X to the 1/2 plus 1, doing the front, so 1/2 plus 1. So that's simply equal to what? 3x to the 3/2 over 3/2, right? And just simply when you do 3 divided by 3/2, give you just 2. Okay, so you got 2x to 3/2. You're evaluating x equal to what? 1, x equal to 4.
Why did you do 2?
Okay. So 3 divided by 3 over 2, class, okay? 3 over 3 over 2. Is everybody with me?
So I'm trying to figure
What
out
about the
where
other
you-
ones?
Huh?
I'm like right here where you got, not there, like right above it.
Mm-hmm.
The one over to the left.
Mm-hmm.
The left, up, 3, the 3 right there.
Yeah.
So why did you use 3 instead of using the 4 or the 1? Is what I'm
Because
confused
the
about.
3.
This 3 can be this 3.
Okay.
That 3 came from this constant 3. Yeah.
Okay.
Okay, this 3 is just a part of the problem. And this 3/2 is what we figured
And
out.
so
right?
if it's there, you don't do the 4 other one? Like how we did the last step, or the last problem, the example that you just did?
So those, okay, this is just 3 times that, so we don't have to.
Okay.
So is everybody with me? But does everybody understand this is 2 because of this, right?
Is there a way that like you could just leave the 3 in there and do it?
I'm sorry?
Like, could you just leave the 3 inside?
Yeah.
Or do you-
Yeah, if you want to, yes. Yeah, you don't have to, but 3 is, okay, so I can understand why you guys confused, okay. This is what it is, okay. So if I have a problem like 3x, are you with me, class? Okay. I can leave just like that, or I can just put the 3 in the front, because 3 does not matter. I'm not doing anything to 3, I just multiply 3 later after I do all the work.
Okay.
Are you with me, class? This 3 does not change anything because I'm not adding 1 power or divide by 1 power to this. I'm only doing that, which one? This part, that part only, x part only, okay? So this is different from just the 3 in the dx. This case, the 3 does not really do anything, but this is actually what? 0 power. So I'm doing the adding power and divided by power to the x only, not the number. Are you with me? Okay, so this number you just simply multiply after you do your evaluation. Okay, is everybody with me? All right, so what is this one, class? What's the secant square? What's the antiderivative of secant square? What does it give you secant square? Which trigonometry function? Okay, better memorize it. Tangent, right? This is a tangent. So things like that, I cannot help you because you are, you're supposed to memorize it. Are you with me, class? Okay, so antiderivative of secant square is a tangent. So you've been doing this problem, so I don't really have to go over again because we've been doing it since about 4.3 for 2 days. What is this? I didn't add right. Tangent, not 2.
Cause I mean the 1 and the 4, I was just thinking, I'm like.
Oh, no, I didn't finish it. I didn't finish my problem. Remember, I only did, I stopped, right? I didn't plug it in, yes. All right, mean value theorem for intervals. Mean value theorem is the one you already know. Mean, what's it mean means, class? Average, that's right, average, right. We've done this. So, mean value theorem says, if I have this graph right here, I can find where the middle is, okay? That the average area. Okay, this area is over here, and that area is what? This much big. Are you with me, class? So average area, the average height will be over here, someplace like that. So if I found, okay, when I do this area, put this area to over here, okay? Are you with me, class? Then I can make it to be what? Rectangle shape, right? So the middle height will be where? Where the C is.
Correct.
So this f of what? C is my middle height. My width is what? A to B. Are you following me, class? That's the concept. Mean value means, hey, I can find the average, I can find the middle one that gives me what? Average value.
Okay.
Does everybody see this one right here? This f of C is what? The height. Is everybody with me?
Yes, yes, yes.
Okay. Sometimes it's not that like obvious, but look at this thing right here. This is a very good example right here. They're telling you this is a square shape. Are you with me, class? The height right here is what? This width is b minus a, right? What's my height over here? F of c. Are you with me, class? So they were telling you this square box right here, this rectangular box, is same as what? The area between where? A to B of what? This graph. So this is kind of think about it, it's kind of weird. I was like, oh my gosh, how did you do that? So weird shape. Like you have this weird shape, and you have no idea what the area is, but I'm going to say, you know what, I can make this into shape that I know, like rectangle. And say, hey, this is the same area as what? This weird shape of area under the curve. Are you with me, class? That's what they did. They're saying, hey, I know the area under the curve is this shape, that curve shape. But I was like, hey, I can make that into a rectangle. If I find what? Height. The average height. So that's average height right there.
Okay.
So we just figured out this, we're looking curve, area under the curve is the same as what? This rectangle. Isn't that weird? That's what calculus can do. So I can say, hey, some weird looking curve. I was like, hey, I can make that into what? Square box for you. You can do magic, okay? Like I feel like a calculus making to be like a magician. You can do magic, When I first learned this, I thought it was like almost like a magic. How can you make this into weird looking shape into rectangle, Are you excited like me? All right, so everybody understand what this means? This is a weird looking curve area. And then I can make that into what? Rectangle. Okay, everybody with me?